Hello everybody, this is Mr. Longo about to talk to you about some parallelogram properties. So we're going to spend a little bit of time just looking at these two diagrams here because these are going to show us where all of the different parallelogram properties come from. Okay? So to start, I'm going to work with this side. We have two sets of parallel lines. We have the blue ones, which are A and B, and they are parallel to each other. And then we have the green ones, C and D, and they are parallel to each other. So what we're going to do is we're going to use a whole bunch of old school information to show you all the different properties of a parallelogram. So to start, we're just going to pick one angle and give it one random measure. So to make math easy, we're just going to say that this is 100 degrees over here. So if we go back to some of our previous units, one of the things that we learned about parallel lines is that the same side interior angles were always supplementary. So since C is parallel to D, if this angle is 100, then the angle that's on the same side and interior is going to be 80 because they are supplementary. At the same time, if A is parallel to B, then these two angles have to be supplementary because they are also same side interior angles. And one last time, since C is still parallel to D, then the same side interior angle from 80 is going to be supplementary, so it is 100 degrees. So the first couple of things that we're going to figure out is the fact that the same side angles are always going to be supplementary, but the opposite angles are going to be congruent. Okay, so those are the first two properties we're going to know about a parallelogram, is that the opposite angles are congruent and the same side ones are supplementary. So just to show that, we'll say that one of them is 180, just like we picked over there. Now, it would work with any set of angles that are supplementary. Okay, so that's the first two properties about a parallelogram that we can discover. So now that we know that, we're going to take things a little bit farther. We're going to get rid of those angles, and the next thing we're going to do is we're going to draw one diagonal for now, and what we're going to do is we're going to create two triangles. As you can see, we have the triangle up here and a triangle down here. So we already know that these angles are congruent. And now what happened is we just put ourselves a new transversal. So let's go back to that same unit where we learned about angles. And we're going to go back and say that alternate interior angles are congruent. So if we were to look at this red line as our transversal for the parallel lines, this angle would have to be congruent to this angle because they are alternate interior angles. Now let's skip to another chapter. We learned that angle side and angle side, using the reflexive property, that those two triangles are congruent. So this triangle up here is congruent to this triangle down here by angle side. Now, another thing you learned about congruent triangles is they have all sets of corresponding sides and angles are congruent. So that means since these are congruent, this top and bottom piece are congruent by CPCTC, and the right and left piece are congruent by CPCTC. So we just learned our second property, or third property, because the angles were both first, and that's opposite sides are going to be congruent. So the left and right are going to be congruent, and the top and bottom are going to be congruent. Okay? So we're going to go discover one more thing. So we're going to get rid of some stuff that we already have. And I'm going to draw in one more diagonal. So this would be the other diagonal of the parallelogram. So what we just did automatically right off the bat is created some vertical angles here. And the other thing we already knew to begin with was the fact that we have these sides that are congruent, and we have these sides that are congruent. We also have more alternate interior angles that are congruent. We know that this guy is congruent to this guy because of alternate interior angles. So one last time, we're going to use congruent triangles again, because what we can now say is these top and bottom triangles are congruent by angle, angle, side. So therefore, by CPCTC, we know that those two are going to be congruent, and those two are going to be congruent. So when you have two diagonals that have been drawn in, they are going to cut each other in half. So diagonals will bisect each other. Okay, so again, this piece is congruent to that piece, and this piece is congruent to that piece. So basically, a parallelogram has quite a few properties, and we just used what we knew from back in the day and wrap it all up into one. So the properties of a parallelogram are opposite sides are parallel. Now that's the definition of a parallelogram. The other properties is that the opposite sides are congruent, which we proved using CPCTC of congruent triangles. The first two properties we found about the angles is that the opposite angles are congruent, but we also know that the same side interior angles are supplementary. And the last thing we just found out is the diagonals bisect each other. They're not congruent, but they bisect each other, so they cut each other in half. Okay, so that little diagram right there pretty much sums up the entire video. Opposite sides are congruent, opposite angles are congruent, and we have diagonals that bisect each other, and we have same side interior that are supplementary. So let's clean up that last diagram really quick so we can see that the opposite angles are congruent. Okay, so that's it. Those are all the properties of a parallelogram that you need to be able to use in further sections of this unit. This is Longo, and I'm out. See you, bye.